Hey everyone, welcome back to day 2 of simplifying radical expressions. Take out those same note sheets that you used yesterday to fill in today's notes. We are going to add variables to our radical expressions today. Let's just go through the terminology one more time so you remember. This is a radical symbol, and everything we write underneath it's called a radicand. Yesterday we did this, and today we're going to do more like this, where we put variables underneath. And we call these either radical expressions or square root expressions when we have a radical symbol plus some numbers and variables underneath it. And then we can go ahead and multiply things together, and we were using this property yesterday in order to simplify things. So today we're going to see that we have variables underneath, and we are allowed to take square roots of even numbered variables. So it's awesome that we can do that. So we have to consider the numbers and the variables underneath this radical expression to know what we can simplify and take out. Again, we're going to simplify these radical expressions. So let's consider the number 5 first. Thinking about my perfect squares, the only perfect square smaller than 5 is 4, and I can't pull a 4 out, so 5 by itself is already simplified. And I can pull out even numbered powers, and so if I just have an x, that's x to the first, that is not even, that cannot be pulled out, but I can sure take a square root of y squared to move it to the outside. The square root of y squared is just a y, because y times y is y squared. So this y can be pulled out and put to the front of this radical expression. And so this gets rewritten, so this got taken out because I took the square root of it and moving it to the outside. So I have y square root, and I said we couldn't simplify anything inside of it. 5x. That is my simplified radical expression. All right, now let's do another one. What do we got going on here? I got no numbers inside my radical expression. I see a 4 on the outside, so that just stays there. And I see a squared, even, c to the 6th, even, b to the 5th is not. So let me show you the first step in doing this. What we always want to do is we want to rewrite every odd number power as an even number power. Now you can't just erase the 5, but what we can do is this. So I'm going to have the square root of 4. A squared is good, and then we're always going to rewrite it as b times, so b to the first, times b to the 4th. This is b to the 5th, okay? So we're going to do that every single time we have an odd number power. We are going to take off one of the variables and then write it times the next power to make it b to the 5th or whatever odd number we're trying to make, and then we have c to the 6th. So now I see I've got 3 even numbered variables inside my radical expression, and I can take the square root of all even numbered variables. So if you're asking yourself, how do we do this? Here we go. The square root of a squared is a, so that is gone. I cannot take the square root of this because it's b to the first, which is odd. The square root of b to the 4th is b squared. We simply have the power to take the square root. And that means the square root of c to the 6th, because I can do that because it's even, is c cubed, and that is gone. I like crossing them off as I take the square root, so I know I don't rewrite them. The only thing I've left under that radical is a b. This a comes out, this b comes out, and this c all come out in front of the radical expression. I had a 4 there to begin with, don't lose it, and I should keep my variables alphabetical. So I'm going to have a, b squared, c cubed, and then I had left just one lonely b in there, but that has to stay inside. That is my simplified radical expression. Number 7. All right, 189. Our numbers are getting a little harder now. Calculators might be your friend. Let's start with the number 189, and then we'll rewrite those odd numbered variables in a moment. So let's start with 189. Now, as a reminder to do this, I need to think of my perfect squares. 1, 4, 9, 16, let's keep going for a minute, 25, 36, and on and on and on. And what I want to do is take my calculator and start dividing. So I have 189 divided by 4. I hope off the top of your head you realize that's not going to work. So let's take 189 divided by 9. Oh, that's 21. So I'm going to rewrite this as 9 times 21 because 9 is a perfect square. And think about 21. There's no more perfect squares up here left in it, so that's my biggest one. Now I'm going to rewrite m to the 5th as an multiplication problem to make an even power. I'm going to take 1 off, And that would leave me m to the 4th left, because m to the 1st times m to the 4th is m to the 5th. N cubed is also odd, so it's going to be n and n to the 2nd. Now I have some even numbered things, and let's take out what we can with perfect squares. 9 is a perfect square, so I take the square root of it, it's 3. I did the 9, it's done. 21 stays. I can't take any square root of that. M stays. It's odd, so I can't take the square root of that. I can take the square root of m to the 4th. Remember, we just have it, so it's m squared. I cannot take the square root of an n to the 1st, but I can of n squared. And take the square root of it. I just have it, so n squared just becomes an n. And those 3 get moved outside the house. So I have 3m squared n. And inside I was left with a 21, an m, and an n. Now reevaluate what you have inside your house. Could you take, inside your radical, could you take a square root of 21, m or n? No. 21, no perfect squares. M and n are odd. So that is your simplified radical expression. All right, 2 more yet. So 162, again, our numbers are getting a little bit harder here. They're getting a little bit harder. So we're going to go ahead and look at some of these. So let's write some perfect squares down. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. There's the first 10 perfect squares for you. So what I'm going to do is I'm going to start dividing. So let's say 4. 162 divided by 4. That didn't work. It's 40.5. 162 divided by 9. Now, let me write that down because I know you can't see me. 162 divided by 9 is 18. Here's the deal. I know that's not the biggest one, because 18 still has a perfect square in it. It actually has another 9 in it. And so because it's 9 and 9, the actual perfect square I want to use, the biggest one, is going to be 81. Now, if you screw that up and you don't get to the biggest perfect square, your answer is going to have to be simplified again. So always be thinking ahead, what is the biggest one I can pull out, because it's less work then. So if I take 162 divided by 81, that's actually 2. So let's rewrite this. Square root of 9, it's 81 times 2. Ooh, I have a to the 4th. That's already written perfect for me. It's even. And I can't simplify down a b to the 1st because it's just a b to the 1st. All right, let's take our perfect squares. Let's take the square root of 81. 9. I did that. Cross it off. 2, we can't take a square root of. A to the 4th we can. That becomes a squared. Gone. B we cannot. So I need to bring these out to the outside of the house. So I'm going to write a little extra stuff. I have negative 9 times a squared. And in my house, I was left with a 2 and a b. So I actually need to do this multiplication. Negative 9 times 9 is negative 81, a squared, square root of 2b. All right, that's my simplified answer. And think about what's in your radical. 2b cannot be, no more square roots can be taken of 2 or b. All right, last problem. 320, a squared, b10, c to the 12. Okay, so 320. We got to figure out what the heck goes into 320. So let's start dividing. I got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. We'll see if that's enough. Okay, so let's do 320 divided by 4. I get 80. That seems a little big yet, an 80. So let's go a little bigger. 320 divided by 9. Doesn't work. It's a decimal. 320 divided by 16. Next number. Ooh, we're getting there. That's 16 times 20. So probably not quite enough yet, because 20 has a perfect square in it. Here, let's write that down. So 16 times 20 is 360, but that 20 is probably not quite right yet. So let's go a little higher. So 320 divided by 25, no good. 320 divided by 36, no good. 320 divided by 49, oh, decimal number. Let's try 320 divided by 64. There it is. It's 64 times 5. I was just going up this list and checking all these numbers. I see 64 is a perfect square and 5 is not. And so that one will work. Oops, I should say 320 here. Mistake on my part, but that is 320. All right, so let's start taking some square roots and figuring this out. I have 3a on the outside. I have a variable now, which is fine. Rewrite this 320 as a multiplication problem. And then rewrite any odd powers. But if you look, I got no odd powers this time, which is fine. I can take the square root of each of those. All right, so let's take some square roots. The square root of 64, and that's going to be gone, is 8. 5 stays. A squared square root is a, so that's gone. The square root of b to the 10. Remember, you have it, so it's b to the 5th. Gone. The square root of c to the 12 is c to the 6th. You take half of it. And there's everything I pulled out. All I was left was with an 8 or a 5 left inside of it. Perfect. All right, let's rewrite what I have in extra steps. So I'd have 3a times 8 times a times b to the 5th times c to the 6th. I'll simplify that down for you. And then left in the radical is just a 5. All right, well, let's simplify this. I can combine my numbers, and I can combine my a's. So 3 times 8 is 24. A times a is a squared, and then I don't have anything else to combine, so I just write it all out. And that is my final answer. Good luck with simplifying radical expressions. Hopefully I get to see you real soon. Miss you all, and let me know if you need any help with anything. Have a great day.